Okay, there was a problem with my graph of y2, which is why what I saw on the graph didn't match what I was expecting to see. And of course, this is how we work with mathematics. We always check ourselves in one way or another, and I was checking to see that the graph was completely consistent. I was also trying to illustrate some important relationships and graphing techniques. So, the problem is just my mental arithmetic. When I evaluated y2 at 100, I got 200 here, I got minus 400 here, and I then got minus 200 from this, and I added it to 400 to get the y value of the vertex. What's wrong with that? Well, that 400 was for the y1 function. I should have added it to 300, just being careless and doing it quickly, and found the wrong vertex. So the vertex here is at 100. The vertex here is at y equals 175. So at 100, this function has its vertex. At 150, 175, this function has its vertex. This is the y1, excuse me, and this is the y2. Now, from the graph, but especially from the equations, because the graph isn't all that accurate, we seem to confirm that at t equals 50, both of these velocities are negative 2. Now, we didn't set out to find when the velocities were equal. We just found that accidentally because the negative 2 was chosen without any thought that they might actually be the same. In any case, this is what we got. So at t equals 50, y1 is 275, and y2 is 150. Now, does that match what we have here on the graph of y versus t? Well, when t equals 50, the y values will correspond to this. And I'm not fudging this. This is what I get. So the y2 function will have this value. The y1 function will have this value. Now, the y1 should be 275. Is this plausibly 275? Well, yeah, that's very plausible. And is the y value here 150? Yeah, that's also very plausible. Okay, here's 100, here's 200, that one hits it pretty well. Here's 200 and here's 300, that one hits 275 pretty well. So now my graph makes a lot more sense. Now the thing I wanted to really look at though is the slopes of these two graphs, because these velocities are the instantaneous rates of change. These are the rates of change. Are the rates of change equal? Are the rates of change both negative 2? The answer is, I didn't draw my curves all that well. So even though the values appear to match, well, let's just draw the tangent lines at those points. Right there is the slope of this graph at this point. Remember that an average rate of change is defined in terms of slope. Well, the instantaneous rate of change is just the slope of the tangent line. So here's our tangent line to this graph, to the y2 graph, at the point where t equals 50. And we do the same thing with the y1 graph at the point where t equals 150, and we get, well, maybe I'm fudging this a little bit. Okay? These lines aren't quite parallel, but they should be. Okay? The slope of either graph is the rate of change, which is the v, for the v function corresponding to that graph. Slopes should be equal. and that implies equal slopes. Okay, now there's a little discrepancy. This slope is not quite as, this is not quite as steep as this, but it's plausible that if the graph was drawn with complete accuracy, we would have equal slopes. And that's an important aspect. Now, you might be asked to draw, to graph your, to do your v versus t graphs for the two functions. You might be asked to find the velocities for the two functions. If you are, you'll be given the formula that, that the velocity is going to be 2at plus b. You might be asked to construct this graph. You might be asked to do a variety of things. Okay? So you just have to basically have the skills of the course, because the course is addressed how to draw a graph of a linear function, and these are linear functions, first power of t. Okay, these are quadratic functions. We know how to graph quadratic functions. So this project kind of pulls a lot of that together. Doesn't address exponential and logarithmic models, but we have other problems that do. Okay, I want to talk just a little bit more about the relationship between these two graphs and what this graph can tell us.